We are continuing with the question number 14. For the circuit shown in figure, the capacitance measured between terminals B and Y will be. So, these are our terminals B and Y. We will have to find out the equivalent capacitance. Okay. So, they won't be normally asking you with the resistance reduction because it is more comfortable for us. So, they will be making us slightly uncomfortable with the they are trying to make us slightly uncomfortable with the capacitance because we know the capacitance principle is just opposite of a resistor. When resistors are in series, we will sum it up. When resistors are in parallel, we will go for the reciprocal sum. When resistors are in parallel, we will go for 1 by R equivalent is equal to 1 by R1 plus 1 by R2. But for a capacitance, when they are connected in parallel, we will just add them as C1 plus C2 etc. up to Cn. So this figure we are going to slightly rearrange in this format. So this figure becomes into this format as CC with the CS, CC, CS and CC. Okay. So these two capacitance CS, CC and CS, CC are exactly in parallel. So we can take it to be the sum of CS plus CC. Okay. So since they are in parallel, it will become CS plus CC. Okay. And here also it will become CS plus CC. Okay, so it becomes two CS plus CC which are connected in series. Okay, so when they are connected in series, it becomes CS plus CC divided by 2 plus another CC is there. Okay, so CS plus CC divided by 2 plus CC will finally give you the answer of CS plus 3 CC divided by 2. So what is our answer? Our answer is CS plus 3 CC divided by 2, or answer option is C for question number 14. Now moving into question number 15, RMS value of a half wave rectified symmetrical square wave current of 2 ampere is what is the question. RMS value of a half wave rectified symmetrical square wave current of 2 ampere. So we will have to draw the symmetrical square wave and its value is 2 amperes. So we are going to find out the RMS value of this I of t. Okay, so this is the symmetrical square wave from 0 to t by 2 and from t to 3t by 2 and then from 2t onwards. So we are going to find out the RMS value. What is the equation for IRMS? IRMS is equal to 1 by t integral 0 to t I square t dt. So it is 1 by t integral 0 to t I square t dt. It's a direct question. When you are going to substitute the value, you will get it as root 2 ampere. Root 2 ampere. So what is our answer? Our answer is option A, which is root 2 amperes. So that is about question number 15. Now moving into question number 16. Here also the pattern is repeated. We will have to find out the locus diagram. But here we are not asked to find out the locus diagram of the current. Here we have to find out the locus diagram of the admittance of the RLC circuit. So we will just read the question. Okay. So when you are doing these multiple questions, you can see that the same pattern of question is repeated again in 1991 for 2 marks. So once you do this question, you will easily get 2 marks from this question. So a fixed capacitor of reactance J.02 ohm is connected in parallel across a series combination of a fixed inductance and a reactance J.01 ohm and a variable resistance R. Now as R is varied from 0 to infinity, so here also R is going to vary from 0 to infinity. So R will vary from 0 to infinity. The locus diagram of the admittance of the RLC circuit is what is the question. So the locus diagram of the admittance is to be plotted. So we will have to make equation for admittance. So this is the given diagram. This is the given figure. So it is minus J.02 and R plus J.01 ohm. So here we are going to make equation for admittance YAB. So what is equation for admittance YAB? YAB is equal to 1 divided by minus J.02 plus 1 divided by R plus J.01. And in this we are going to substitute values from R is equal to 0 to R is equal to infinity. So we will start from R is equal to 0. We will finally go to R is equal to infinity. And in between we are going to substitute R is equal to J.01 ohm. So from this we will obtain 3 values of YAB. These are the values of YAB that we are obtaining, and then we will have to plot these values. Okay, here you can see one point is on the minus 90 degree axis, one point is on the plus 90 degree axis, and one point is on the real axis. So that means definitely this is a semicircle. So that means there is a point on the plus 90 degree axis, there is a point on the minus 90 degree axis, and there is a point which is 50 on the real axis. So you can see that from r equal to 0, what is r is equal to 0? When r is equal to 0, it falls on minus 90 degree, and r tends to infinity, it falls on plus 90 degree. So r is equal to 0, it falls on minus 90 degree. R equal to infinity, it falls on the plus 90 degree. So it goes from r is equal to 0 to r is equal to infinity. Okay. So here you can clearly see that this admittance locus is a semicircle, and its diameter is j100, because it is on the positive side it is 50, and on the negative side also it is 50. So it is j100, which is the total diameter of the semicircle. So what is our answer? Our answer is a semicircle of diameter j100 ohm and center at 0. So it is a semicircle with a diameter j100 and its center is at origin. So our option is option A for this question. Now moving into the next question, when a resistor R is connected to a current source, it consumes a power of 18 watts. When the same R is connected to a voltage source having the same magnitude as the current source, voltage source having the same magnitude as the current source, the power absorbed is 4.5 watts. Now the magnitude of the current source is to be found out, and you will have to find out the value of R also. Okay, so a resistor is connected to a current source, and the same resistance is connected to a voltage source. So a resistor R is connected to a current source, the same resistor R is connected to a voltage source. Okay, so here the power is 18 watts. So that means I square R is equal to 18 watts. When the resistor is connected to an voltage source having the same value as current source, it consumes a power 4.5 watts. So I square R is equal to 18 watts and V square by R is equal to 4.5 watts. Now V is equal to I in magnitude. So we can substitute V is equal to I. So in the first question we get it, figure we get it as I square R is equal to 18 watts, and in the second equation we will get it as I square by R is equal to 4.5. So we get equation number 1 and equation number 2. Equation number 1 is I square R is equal to 18, and equation number 2 is V square by R is equal to 4.5. Substituting V is equal to I, because V is equal to I, so it becomes I square by R is equal to 4.5. So solving these two equations, you will get the values of I and R. So I comes to be 3 amperes and R comes to be 2 ohms. So that is what is our answer. So what is our answer? Our answer is option B, 3 amperes and 2 ohms. So that is about question number 17. Now moving into question number 18. Current I1, I2 and I3 meet at a junction or a node in a circuit. All currents are marked as entering the node. So that means there are 3 currents entering a node. All of them are marked as entering the node. I1 value is given, I2 value is given, then I3 is to be found out. This is a question of pure Kirchhoff's current law. The pure Kirchhoff's current law. So what at any junction, what is our Kirchhoff's current law? Algebraic sum of currents is equal to 0. So that means I1 plus I2 plus I3 will be equal to 0. So we can substitute I1 and I2, then we will have to obtain the value of I3. So here I1 plus I2 plus I3 is equal to 0. I1 is given, I2 is given, we will have to find out the value of I3, and you can solve the equation and find the value of I3. So it comes to be minus 10 cos omega t plus 36.87 milliamperes, which is our option D. So for question number 18, we will go with option D. Now question number 19. The circuit shown in the figure is equivalent to a load of, is what is the question. The circuit shown in the figure is equivalent to a load of. So here it is 2 ohm, here it is 4 ohm, and then here it is 2 times I, which is a dependent voltage source. So we will have to convert this circuit into its equivalent load. So we have taken down the figure, and we are going to find out the currents. We are assuming that this is total current I, and this is current I1, and this is current I2. Now what is I1? I1 is, this is the voltage is V. Across this combination, the voltage is V. So what is I1? I1 is V divided by 4. I1 is equal to V divided by 4. Now we are going to find out the current I2, which is the current through the 2 ohm resistance. So the current through the 2 ohm resistance is actually, what is the voltage at this point? The voltage at this point is V. So it is V minus 2I. V minus 2I divided by 2. So I2 is equal to V minus 2I divided by 2. And you see I1 plus I2 is the main current I. So what is main current? Main current is I1 plus I2. So we can sum for V by 4 plus V minus 2I divided by 2. Okay. So from this you will get it as I is equal to V by 4 plus V by 2 minus I, or you can bring this I to the left hand side, it becomes 2I is equal to 3 by 4V. Okay, now what is our load? Our load is Z, isn't it? Z is equal to V divided by I. So you can convert this equation in the form of V divided by I, and you will be getting answer as 8 by 3 ohms. So what is our answer? Our answer is option B, 8 by 3 ohms. Option B, 8 by 3 ohms is what is our answer. So that is about question number 19. Now moving into question number 20, the impedance seen by the source in the circuit in the figure is given by. So this is our impedance ZL, which is 10 angle 30. The impedance seen by the source in the circuit in the figure is given by, is what is to be found out. This is also a question which involves mutual inductance in the form 1:4. In the form 1:4 is the turns ratio that is given, N1 and N2, and then there is the dot convention also. This is a question from GATE 2000 of 2 marks. So the impedance seen by the source in the circuit is what is the question. So we will have to convert the impedance on the right hand side to the left hand side. So how can we convert the impedance? Our impedance is ZL. ZL is 10 angle 30 degree. Okay. So it is 10 angle 30 degree. And what is our turns ratio? Turns ratio is 1 by 4. So it is K square Z. So Z2 dash is equal to K square Z2. This is the equation. Z2 dash is equal to K square Z2. So that means an impedance on the secondary, if you multiply it with the K square, you can take the impedance reflection into the primary. So this is what is called the referring of impedance from secondary to primary. So you multiply it with the K square, Z2 gets converted from the secondary towards the primary, because we want to eliminate this non-electric magnetic coupling. So we have to convert we have to refer the secondary impedance into primary. So to refer the secondary impedance into primary, we are multiplying it with the K square. And what is the impedance already existing in the primary? It is 4 minus J2. So it is 4 minus J2 plus 1 by 4 the whole square plus whole square into 10 angle 30 degree, which will come to 4.54 minus J 1.69, which is option C, 4.54 minus J 1.69 ohms, which is option C. So that is about question number 20. Now we are moving into question number 21. Given two coupled coils with L1 and L2, their mutual inductance M satisfies. What is the equation of M? M is equal to K root L1 L2, isn't it? Two coupled coils, two coupled inductors L1 and L2 are given. The mutual inductance M satisfies is what is the question. So M equals K root L1 L2. When what is K? K is the coefficient of coupling. What is M? M is the mutual inductance. What is L? L is the self inductance. So K normally varies from 0 to 1, isn't it? So K normally varies from 0 to 1. So that means M is either equal to root L1 L2 if K is equal to 1. And if K is less than 1, then M is less than or equal to root L1 L2. So what is our answer? Our answer is M less than or equal to root L1 L2. You have to remember these kinds of questions, because for other public sector examinations, this kind of question will directly come, because it is a theoretical question which depends only on the simple equation. So as many questions we practice, we have to remember the patterns of these questions. Like a slight difference is coming for our examination, then also we will have to answer this question. So when two coupled coils L1 and L2 are given, their mutual inductance M is less than or equal to root L1 L2. Now moving into question number 22. Two incandescent light bulbs, 40 watt and 60 watt ratings. So this is 40 watt and this is 60 watt. Rating are connected in series across the mains. So it is connected in series across the mains. Then the bulbs together consume 100 watts. The bulb together consume 50 watts. The 60 watt bulbs glows brighter. The 40 watt bulbs glows brighter. So for this question, our answer is D. the 40 watt bulb will glow brighter. Okay, and how it happens? Because power is inversely proportional to resistance, isn't it? So what is P? P is equal to P square divided by R. So it is inversely proportional to resistance. Therefore, the resistance of the 40 watt bulb is greater than resistance of 60 watt bulb. You have to always remember this. Always remember this. Okay. So when your power is higher, your resistance is lesser. Okay, and when your power is lesser, your resistance is higher. So that means your 40 watt bulb is having a higher resistance. Okay, and they are connected in series. When they are connected in series, the current passing through both of them will be the same. Okay, and now what is power dissipation? Power dissipation is I square R, isn't it? The I is common for I1 square R1 and P is equal to I2 square R2. And you see current is common because they are connected in series. But R1, R2 varies. R resistance is higher for the 40 watt bulb. So what happens is the I square R drop across the 40 watt bulb will be higher compared to the 60 watt bulb. So what happens is that the power consumed by the 40 watt bulb will be greater than the power consumed by the 60 watt bulb. Hence the 40 watt bulb glows brighter. This is a typical question that comes normally for every public sector examination. So this is a real typical question. In addition to this also, there can be questions that comes from R is equal to rho L by A. What happens when the length is doubled? What happens when the radius of cross section becomes half? That kinds of question can also come. So this is a typical question, and you have to remember this because when it is connected in series, the lamp with the lowest wattage will glow brighter, because always the lamp with the lowest wattage will have the highest resistance, because power is inversely proportional to resistance. When the power of the lamp is high, resistance of the lamp is low. Power of the lamp is low, resistance of the lamp is high. So now moving into question number 23. Considering a star network shown in the figure, the resistance between the terminals A and B with C open, resistance between the terminals A and B with C open, is 6 ohm. So that means RA plus RB is equal to 6. Okay. So that means RA plus RB is equal to 6. Okay. In the second case, the resistance between the terminals B and C with the A open is 11. So that means RB plus RC is equal to 11. RB plus RC is equal to 11. And the third case, between terminal C and A with the terminal B open is 9. So that means RC plus RA is equal to 9. RC plus RA is equal to 9. You can solve these three equations. Then you will be getting the value of RA, RB and RC. RA is equal to 2, RB is equal to 4 and RC is equal to 7. And then our answer is option B. RA is equal to 2, RB is equal to 4, RC is equal to 7. So it is 2, 4 and 7. It is 2, 4 and 7. So that is what is our answer. So directly you can solve these equations and get the answer. Question number 24. In the circuit shown in figure, it is found that the input AC voltage VI and current I are in phase. So that means it is at a resonance. So that means imaginary part is equal to 0 because they are in phase. The current and voltage are in phase. The coupling coefficient K is equal to M by root L1 L2, where M is the mutual inductance between the coils. The value of K and the dot polarity of the coils PQR. So we will have to find out the value of K and the dot polarity of the coils. So input AC voltage and the current are in phase. Okay. So that means the condition is resonance. So that means the net reactance is equal to capacitive reactance is equal to net reactance is equal to 0, or capacitive reactance is equal to inductive reactance. So what is our capacitive reactance? Capacitive reactance is minus J12. Our inductive reactance is J8 and J10. And then there is a coefficient of coupling between these two coils. So we will take it as J8 plus 2K root L1 L2. Okay. So taking the absolute value, 12 becomes equal to 8 plus 8 plus 6K. So from that K is equal to minus 1 by 4, or K is equal to minus 0.25. So coefficient of coupling is minus 0.25. That means the coupling is opposite. So coupling is opposite means if your dot of this is at starting, then this dot has to be at the ending. So our dot has to be at Q. So the dot has to be at Q, and then the value of K is minus 0.25. So our answer is option C, with K is equal to minus 0.25 and dot at Q. So that is answer for question number 24. Now moving into question number 25. A segment of a circuit is shown in figure. VR is given as 5 volt. VC is equal to 4 sin 2t. VC is equal to, this is VC. VC is equal to 4 sin 2t. VC is equal to 4 sin 2t. Voltage VL, we will have to find the value of the voltage VL. Okay, so this is a typical case of Kirchhoff's current law, because everything is meeting at the junction. So we are going to make the Kirchhoff's current law equation. By Kirchhoff's current law, IP plus IQ plus IC plus IL is equal to 0. IQ plus IP plus IQ plus IC plus IL. Where is IC? IC. This is IC. IC plus this is IL. IL is equal to 0. Okay. So IP plus IQ plus IC plus IL is equal to 0. And here IQ is given as 1 ampere and IP is also directly given as 2 amperes. So we can go with the 1 and 2, 1 plus 2 plus IC plus IL is equal to 0. Okay. So this is equation number 1. Let this be equation number 1. And we can also make an equation for IC as IC is equal to C dV by dt, because it is a case of it is capacitance. So this is a capacitance. So we can take it as IC is equal to C dV by dt, and the dV is given. V is given as 4 sin 2t. So we can differentiate it and we will get the value of IC. And you can put the value of IC into this equation, because we already know that IP and IQ are 2 and 1. So that means it is 3. 3 plus 8 cos 2t plus IL is equal to 0, or IL is equal to minus 3 minus 8 to 2 cos 2t. So we have obtained the value of IL, and then what is VL? VL is equal to L di by dt. We have to take the value of I and differentiate and multiply it with L. So it becomes equal to 32 sin 2t, because what is the value of inductance? Inductance is given as 2 Henry. So you can substitute 2 Henry for inductance. So it comes to be 32 sin 2t. Okay. So our IL and VL are obtained. So what is the voltage VL is what is the question. So what is the voltage VL? It is 32 sin 2t. Voltage VL is 32 sin 2t, or our option is option B. Option B for question number 25. Now you note that KCL is based on the law of conservation of charges that I have already explained in the theory classes, as Kirchhoff's current law is law of conservation of charge and Kirchhoff's voltage law is law of conservation of energy. Now going into question number 26. Figure shows the waveform of the current passing through an inductor of resistance 1 ohm and inductance 2 Henry. An inductor of resistance 1 ohm and inductance 2 Henry. Inductance is 2 Henry and resistance is 1 ohm. The energy absorbed by the inductor in the first 4 seconds is to be found out. So we will have to make equation with respect to this. So we can split it as from 0 to 2 seconds and then from 2 to 4 seconds. So from 0 to 2 seconds the current is varying linearly with the time, and then what is I of t? I of t is equal to 3t. Okay, I of t is equal to 3t, and from 2 seconds to 4 seconds, from 2 to 4 it stays at 6 ampere. So from 2 seconds to 4 seconds current is constant and it is 6 amperes. So we are going to find out EL1 and EL2, and then we will add it to become total EL. So what is our EL? EL is 0 to t Li di by dt into dt. So first we will be finding out EL1 and then we will be finding out EL2. So finding out EL1, it becomes integral 0 to 2, because we are going from 0 to 2. From 0 to 2, Li di by dt into dt. So it becomes 0 to 2. L is equal to 2. What is the value of inductance? Inductance is 2, resistance is 1. So L into d by dt of I, you know, I is equal to I of t is equal to 3t. Okay. So then you are reducing this expression, you will get it as 30 joules. You will get the answer as 30 joules. So EL1 becomes equal to 30. Now we will have to find out the value of EL2. Finding out the value of EL2, EL2 from 0 to 4 is current is constant, so there is no use of differentiation, so it becomes equal to 0 joules. Okay, so di by dt becomes equal to 0 of a constant, so hence EL2 becomes equal to 0. Now we have obtained the value of EL1 and EL2, and what is our EL1? EL1 is equal to 30 and EL2 is obtained as 0. Now a pure inductor does not dissipate energy but only stores energy. Okay, due to resistance some energy is dissipated in the resistor. Okay, you can see that there is a resistor which is in series with the inductor and the value of the resistance is 1 ohm. So there is some dissipation that can happen in the resistor. Therefore total energy absorbed by the inductor is the sum of energy stored in the inductor and the energy dissipated in the resistor. So the whatever energy has to be dissipated in the resistor is also to be taken. So the energy dissipated by the resistance in 4 seconds we are going to find out. Okay, so what is energy dissipated by the resistor? It is 0 to t I square r dt. So when you are going to integrate this, the energy dissipated by the resistor, you will get it as 96 joules. You will get it as 96 joules. Okay, what is our answer? Our answer is 132. I think when you are going to do this, so it is 18 into 4 by 2. 18 into 4 by 2 means 18 into 2. 18 into 2 means this is not 30, you will get it as 36 joules. Okay, so it is 18 into 4 by 2, so it is 18 into 2. So this is actually 36 joules that we will be getting as EL1. EL2 is equal to 0. Now we are going to find out the dissipation in the resistance in the 4 seconds, and the dissipation will come to be 96 joules. Okay, so the dissipation comes to be 96 joules. Now the total energy absorbed by the inductor is the previous 36 joules plus this 96 joules, which will come to 132 joules. So our answer is option C, which is 132 joules. 132 joules. So there is a slight correction in this. The answer that is given is not 30, it has to be 36 joules, because here up to this point it is okay, but 30 joules is wrong, it has to be 36 joules. And then the EL2 is equal to 0, so the net energy absorbed by the inductance is 36 only. And then we will have to go find out the dissipation with respect to resistance from 0 to 2 and also from 2 to 4. So when you are summing up 0 to 2 I square r dt and 2 to 4 I square r dt, you will be getting it as 24 plus 72, which will come to 96. So what is total energy absorbed by the inductor? It is the energy for the inductor and also for the energy that is dissipated in the resistor. Energy absorbed by the inductor is actually 36 and energy dissipated by the resistor is 96. So the total energy absorbed by the inductor is 132 joules, which is option C.